Hypothesis testing for a mean, changing a tire example. The length of time to change a tire is normally distributed. A random sample of 10 tire changes is taken with a mean of 22.63 minutes and a standard deviation of 2.98 minutes. Use a 0.05 significance level to test the claim that the mean time to change a tire is less than 25 minutes. So first of all, I'm going to write the claim in words, but I'm also going to use a highlighter to highlight it. Use a 0.05 significance level to test the claim that the mean time to change a tire is less than 25 minutes. Let's write that down in words. So we're going to test a claim that the mean time to change a tire is less than 25 minutes. Okay, so since we're testing a claim about a mean, remember our null and our alternative are going to use the population mean symbol mu. Our claim is less than. So since it does not contain equality, right, it's just the less than symbol, it's not less than or equal to, it's going to go with our alternative hypothesis. So our alternative hypothesis is going to be our claim. And it's going to be HA is mu is less than 25 minutes, which is our parameter. That means the complement H sub 0 is going to be mu is greater than or equal to 25 minutes. This leads us to our underlying assumption. Our underlying assumption is that the claimed mean, we're going to assume, is going to be 25 minutes to change the tire. Our alternative hypothesis, H sub A, since it's a less than symbol, is going to indicate that this is going to be a left tail hypothesis test. Our significance level in our problem, it says use a 0.05 significance level, so it's the 5%. Next, our rejection criteria. We're going to reject the null. Remember, if we're going to use the p-value method, our p-value is going to be less than or equal to our significance level, which is 0.05 in this case. Our test statistic. To calculate our test statistic, we're going to use, remember, a t-test statistic since it's a mean. Our formula, you can look it up on your formula sheet. It's going to be the sample mean x bar minus the claimed mean mu, all divided by s divided by square root of n. I'm going to put parentheses around the numerator and parentheses around the entire denominator there. Now to look up our values. Well, let's read our paragraph again. Length of time to change a tire is normally distributed with a sample of 10 tires is taken with a mean of 22.63 minutes and a standard deviation of 2.9 minutes. So n is 10. The sample mean x bar is 22.63. And the sample standard deviation is 2.98. Substituting these in, x bar is going to be 22.63 minus the claimed mean, which is 25, all divided by s, 2.98, divided by square root of n, which is 10. I'm going to put an extra set of parentheses around the numerator and the whole denominator. There we go. Get out our calculator, and we're going to type this in. So open parentheses, 22.63 minus 25, close parentheses, divided by, open parentheses, 2.98 divided by square root of 10, and then close parentheses and hit enter. That's going to give us negative 2.51496579. Now, the p-value. We can look it up on a chart, but I'm just going to go ahead and use technology here to do this. On StatCrunch, we're going to go to Stat, and then since we're testing for a proportion, or I'm sorry, for a mean, we're going to use t-stats for the mean. One sample, and then with summary. Our sample mean in this problem is 22.63. Our sample standard deviation is 2.98. Whoops, let me always forget to do the different box. 2.98 is in the sample standard deviation box. The sample size is 10. And we're doing a hypothesis test for a mean. We're performing that. So h sub 0 mu should equal, and remember we're using the underlying assumption is 25. H sub a, we're going to change the inequality then to less than. We're going to go down further in the StatCrunch menu site and hit the p-value plot. Then we're going to hit compute. Hitting compute, I'm going to go ahead and hit the right arrow at the bottom right hand corner, and I can see our t-distribution is negative 2.515 is a rounded answer for our test statistic. Our p-value is 0.0165, and then I'm going to copy the t-distribution graph onto my paper. Notice this how skinny the graph is because it's different than a z because it's a t-distribution. So like the z, I'm going to have a scale of -2, -1, 0 being the mean, 1 and 2. Negative 2.51 is my test statistic, our t-test statistic. So t equals negative 2.51. And remember it's a left tail, so I'm going to shade to the left of that value. This gives us our p-value in that shaded region, which is 0.0165. I'm labeling that shaded region. Now, our decision. Remember, our decision comes from our rejection criteria. We're going to reject the null hypothesis if our p-value of 0.0165 is less than or equal to 0.05. Add a couple of zeros to 0.05, and I'm going to definitely 165 is less than or equal to 500, so that means my decision is we're going to reject the null hypothesis. Now, our concluding statement. We're going to have to look at our chart. Remember, there's a couple charts we can look at. We'll look at different ones in different videos. We first ask ourselves, does the claim contain the condition of equality? And the answer is no, because remember, HA was mu is less than 25. It did not contain equality. Then we go down and answer the question, do we reject the null hypothesis? The answer is yes. We reject the null hypothesis, so it would be the sample does provide sufficient evidence to support the claim. Let's write that out in words. So writing this out in words, we would say the sample data does provide sufficient evidence to, we'll say, support. So basically it does support the claim that and we're going to see what we highlighted up here, where we wrote down that the mean time to change a tire is less than 15 minutes, and we state the significance level at alpha equals 0.05. So pretty much they're saying that the average time for everybody should be able to take the change of tires should be less than 25 minutes. I'm sorry, that should be less than 25 minutes, not 15 minutes. There we go. Okay, there we go. We go through this 7-step process.